we're going to be coding up this nice model of how we can distribute food around the world. We're going to be creating the map, creating the city class, and populating it with data that we've handled and cleaned so that we can look at the production of food, estimate the surplus of food for each country, and how that could be redistributed to help solve world hunger. So this is the setup I'll be using, where we've got the terminal, we'll have a little demo of the code and the IDE that we're writing the code in. But before we get started in all of that, I just want us to have a quick look at the structure that this code's going to take within the folder. So here we can see the folder that's containing this, called Global Food Distribution. And there's a number of files in here that we're going to add as we build this program up. But to begin with, we're just going to have a look at the main file, which is going to be our main program file, the thing that we run, our support functions file, and that's going to house a whole load of functions that are going to support this program, and the class city file, which we will start to build up as we introduce cities into our map. We also have this background picture, and we're going to require a map reference, which I'll explain as we get to it. Oh, and a text to font file here as well. So all of these files you can get from my GitHub, which is linked in the description. So the first thing we're going to do is just set up a basic Pygame window. So here we have our super simple main file, and let's just have a look what happens when we run this. And there we can just see a black screen in the bottom corner because we haven't set this background to anything yet. I'm going to just add a comment to this top section because what we're going to try and do is manage all of the user input within this top section. So we can just say managing user input. We want to add an image into here. So what we're going to do is create the background surface. So our background is going to be equal to that image we had within that folder. And we're going to need to transform it a bit, and we'll convert the alpha, and then we're going to have to convert it to make sure, transform it I should say, to make sure it fits well within the window. And we're just going to use our width and height parameters. In order to make it appear, we need to blit it to the screen. So we can create a new section, we can call it displaying objects, and the first thing we're going to do in there is screen.blit, and I should just scroll up a bit, background, and we're going to put it at 0, 0 so that it fills the whole screen. So let's save this and see what happens. And here in the bottom corner, we can see the map image that we're going to start to overlay our items on. Now, this was very handily got from Pygame, a tremendous resource for images, and I will put a link in the description. Now, to make this more exciting, we need to add cities. What we're going to do is place the capital city at a location and use that as a proxy or the distribution center of the country. So we need to move over to our cities class file. So the first thing we're going to do is create a class city, and within this, we're going to want to define an initializer, which is going to take the name of the city and its X and Y position. And then we can just convert these into variables for this object. So name, self position is equal to XY. And we're going to also give it color variables. This is just for white, and a radius, because we're going to represent them as circles. That's all we're going to do in the city class for the time being. We will add more features to this, but that's a good starting point. Now this is also where we want to think about how we're going to initialize all of these. Now, rather than writing a function that does this inside our main file, what I'm going to do instead is move that over to our support functions. And we're just going to call something quite simple here, like cities, and we're going to say is equal to sf.create cities, and that's just using this support functions file. So if we go over to our support functions file here, we can create that function, and to begin with, it's going to be really simple. All we're going to do here is initialize all the cities using the city class, which of course means from class city we need to import the city. But there's something else we need to import here as well, and that's where I want us to have a quick look at one of those files called map reference. This is just a lot of hard work that I did off camera, which was effectively going around that map and using my mouse click to get the location for each capital. And so this is just an X and a Y position. We're going to iterate through it and create cities based on the name and the X and Y position here. So we're going to need to import it, which we're going to do up here. So from mapref, import indices, and then we're going to make use of those indices to quite simply do this. So we're just iterating through everything that came through all of those countries' capital cities with the name of the country, the X and the Y coordinates, and then we just want to return cities. So now we've created our cities, but we're not doing anything with them. We're not showing them. We can go down to our displaying objects and we can draw the cities as circles. So we can say that for city in cities, pygame.draw.circle, and we want to draw it to the screen. We can take the color object of the city. Let me scroll up a second. We can take the position of the city, and we can also take the radius of the city. So now let's save this and run it and see what we get. And there we go. Now it's very hard to see that on this little demo, so let's expand this to a full window. Now in this full window, we can see in each of these places, there is the dot for the city. But what would be really nice is when I hovered over them, if it would show us what country that was representing. So let's just add that feature in, and then we'll start to look at importing data about food production. So we're going to start off in our support functions file. Now one of the things I'm going to want to actually import into here is Pygame, because we're going to use some little functions we create in here to help us draw things within Pygame. But first, I just want to add a basic geometry functions section, and that's because, and this thing we've used in so many other videos, I'm just going to copy and paste it here. This is a simple Euclidean distance formula. It allows us to get the distance between 2 points of multi-dimensional space. We're also going to want a couple of other things in here, which I'm going to call basic Pygame and display helper functions. Down here, we can call this one our city functions. So let's create a few of these Pygame functions. We're going to have a draw text, which is also covered in another video. So what I'm going to do is just copy and paste this. And we're also going to have a draw label to draw our little labels showing the country that each city is representing. So we're going to need the name of that appears on the label, the position of the label, screen, and the font of the label. Now the width will be equal to the length of the name times, I think it was about 6.5 plus 18. These are all little values I've played around with. You'll realize this is a bit of a janky way to do it, but I played around with some factors and got this to work nicely. Let's go text surface is equal to pygame.surface, and we'll use the width, and we'll make it height of about 30. Text surface. We want to have a fill to this surface, but we're also going to add an alpha so that it's got some transparency. And we need to blit it to the screen. And we'll draw some text on top of it using the function that we just wrote above it, which will take the screen, font, name. We give it a font size of 14. And then there's a bunch of position stuff which I believe I just worked out by sort of tinkering with it, so this might not be the best way. It's gone off the screen a little bit, but we basically have the draw text with screen, font, name, font size is 14, so you can see how we're filling this up here. Size 14, position of X, position Y, and the colour being white. So let's just save that. We now need to go to the city to make use of this, and we're going to write an update function, the screen and font, and what we're going to do is go self show label on hover. So when we hover over it, we show the label. Oh, we're also going to want the mouse position because we need to check the mouse position to see if we're hovering over the thing, and we're just going to pass all of that to another function. So let's now write our show label. Import support functions as SF. So if SF Euclidean distance, and I can take the mouse position and the self position. So if the distance between where the mouse is and the center of this city is less than self.radius, we're within that circle that represents the city. And so we should draw the label, and we can use self.name, so the name of this city, self.position, the position of the city, screen, and font. We need to call this update function within our main, otherwise it won't do anything. So if we go to our main file, and down here where we're drawing the cities as circles, we can add in that update as well. We can say city.update mouse position. We haven't got that just yet, but we will in a second. And font name. And the font name is just coming from where we initialize the font up here. And so we want to get our mouse position, which we can get using Pygame, is equal to pygame.mouse.getPos. So let's save this and let's run it. So here we are. You can see that there's the United Kingdom, Iceland, what have we got over? We've got the United States of America, Brazil, got Madagascar over here, Australia, China. So you can see that we've got these labels appearing. So we can now super easily just have a look at what country the dot is referring to when we're moving the food around. So now we want to add some data to our map. And for this, I'm going to use the Food and Agricultural Organization of the United Nations data. It basically collects production data of, well, all manner of things from every country in the world. And you can use this interface to download this data. And what you get when you download this data is something that looks a little bit like this, where we have the product, in this case, is for cereals, so cereal crops. We have the country, the years, population, and production in tons. And what we can do is consolidate this information into something like this. So we've got the country, the year, its population in that year, and then the production of cereals, fruit, meat, tubers, vegetables, and sugar over the course of that year in tons to give us a total production value here. So we have this data set, and then what I was interested in doing is basically just having the country with the population and the country with the production data. So by using this very simple script, I was basically able to convert this data into two JSON files that have this set. So we have the country to populations data and the country to production data. Now this data is actually these two JSON files here. So let's import these files and then we'll see what we can do that's useful with them. So we'll go into our support functions. So we're going to need to have JSON imported so that we can access these files. So I'm actually just going to add a little bit into here. So let's load the population and production data, and we'll do that using the with open country populations main.json, and we're just going to open that to read it as file populations equals json.load file. So we've now just stored all that information in this populations variable, and we can copy this and we can just change this to production and this to production. And now we've loaded all this information. We can print populations and just see what happens when we run this. And then also we'll just exit the program after that. So let's see what happens when we run this. And here we go. You can see that we've got this in a dictionary form where we have the country name and then its population for 2020. Now what we're going to want to do is actually make use of this information. We're going to want to update our cities with it. So we're going to need to update each city with the loaded information. So what I like to do is sort of declare them in the initializer here so that we know what we're supposed to really be getting here. So all I'm going to do is prepare a whole bunch of values here, so population and production. We can also calculate the surplus at the same time, and we're going to see how we're going to do that. So let's save this, come back to here, and what we can do is use this information to update our cities. So for city in cities, if city.name is in the populations keys, then we can say that the city population is equal to the integer value of population's city name. So we're looking it up with the city name, and we can just carry this on to get the production value as well. But instead we're going to use production city name. So we're using the name of the city to look up this information, and we're also going to want to add the surplus. Now the way we're going to calculate surplus is quite simple, because we're going to take the production of the city or the country, and we're going to take away from it the integer value of the city population times by 0.55 of a ton or 550 kilograms. When we look at the average consumption of a European, it's typically around 750 kilograms, or 0.75 of a ton per year. But when you're looking at what you need to survive, which is what we're looking at here, can we feed the world viably? And of course, if there's leftover, we can always add a bit extra. Then 0.55 is a good approximation. So what this allows us to do is remove the population's consumption locally and figure out how much is left over, or the surplus. Now, of course, some places aren't included within the city list, so what we can do there is have a catch-all case, which basically says if you can't find anyone, just set our city population equal to 100,000 and set the city production equal to 0 and set the city surplus equal to minus 55,000 tons. We want to be able to see the production or the surplus of each country, or the populations. So we want to be able to use our city class to alter maybe something like the radius or the colour dependent on those variables. So what we're going to do is within our update function, we're going to add two more update functions, update colour and update radius. So what we can do is have the update colour here and update radius here. So within these two functions, we want to do something dependent on either our population, production or surplus data. And we can say that if self.production divided by, let's say, 15 million is less than 2, self radius is equal to 2, because we don't want them to ever go smaller than that, because then you can't really see them. Else self rad is equal to self.production. Actually, we can just copy it from here, like so. Now let's see what happens when we run this. And there we go. Let's blow this up so that we can see it on the full screen. So here we go, on the full screen. See, China has this huge production. India has huge production as well. United States, huge. Brazil, Nigeria, Russia. It's really interesting actually just seeing the level of production across these countries. We need to have the local consumption taken into account. For example, China and India generate loads of food, but they also have some of the largest populations to feed. So let's take that away and actually plot the surplus. So let's take the surplus instead of the production. Save that and we'll run it and see. And you can see immediately that the map has changed a huge amount. So where India was previously a very big producer, of course its consumption is very high as well, with such a large population. And so it's now much smaller. And everyone has decreased dramatically compared to what they had before, because of course their home consumption or local consumption is high. But we can see that the US, and especially China, produces a lot more than's required to feed people. Now let's carry on and see what we can do with this type of map. I just want to make a brief change to how we're handling some of this code. I would like us to be able to keep a log of the initial surplus, but I also wanted to be able to edit that surplus. So I want another value that basically copies it, and I'm going to call that live surplus. And it's just going to be equal initially to the city surplus. So when I initialize all of this, this is just a copy, but this is going to be the thing that we can edit when we're doing our algorithms. So over also in the class city, we're going to go up here and we're going to have self.live surplus is equal to none, and down here we're going to make this update dependent on the live surplus values. Now something I'd like to do is update the color so that we can see a bit of an effect. So what we're going to do is set some thresholds that if our live surplus is less than minus 1 million, and that basically means a deficit of 1 million or more. So we're going to set that colour equal to a kind of reddy colour. So it's just sort of a dullish red. If the self.live surplus is less than 1, then we'll have the colour just set as a sort of grey or like a off-white. Otherwise, self.color is equal to a kind of blue. So let's save that and see how it looks. And there we go. Really clear coloration of where food needs to move to and where it can move from. It's actually super interesting to see. For example, the UK needs quite a lot of food coming in. And I will just take this moment to also emphasize that we're not considering oils and seafood, nuts and eggs and milk, but we can definitely see that this sort of more arid region around North Africa and the Middle East is very, very dependent on food imports. So now we're going to move on to looking at the algorithms that we're going to use to distribute food within this network. I hope you've been finding this video useful. If you have, why not subscribe somewhere down there? One of the things I just want to get done is tidying up something in the cities class, and then we shouldn't have to look at this cities class again because it has all the things that we need to enable us to carry out all our algorithms. So what I'm going to add up here is just something called self.connections and set it equal to an empty dictionary. So there we go, we've got our connections set up so that we can eventually start adding in cities that link to that one and that move material between them. Now what we want to do is have a look at how we can simply start by finding our biggest surplus, then letting that one share out as much as it possibly can until it either gets down to the size where there's a bigger surplus than that, and then continue sharing down until the whole of the world is satisfied. That's how we're going to start, and then we'll optimize on that situation. So we'll call this first stage something like supplying. And what I want to do is within main, I want to set up an is supplying state here. And initially it'll be equal to false. And that's because I would like us to have to press a key to get it to start. If event.type is equal to pygame.mouse button up is supplying is equal to not is supplying. So we can switch this on and off. Now what we want to do is create a new space just within this while loop, this new area called run supplying algorithm. Within this we'll have a supplier, and at the minute that's going to be nothing. If is supplying, then we want to find a supplier, and we'll call this, we'll set this in the support functions, but we'll call it something like find city with largest surplus, and it will just take all the cities. If we have a supplier, then we can find a city close by, which we can call close city, using a function. And guess what? We'll give this a descriptive name too. We haven't written these functions yet, we're just thinking about how we can describe them. Select closest city in need. And it will take the supplier and cities again. And once we've got this city, if close city, we're going to want another function, and we're going to call this something like transfer food to recipient, and that will take the supplier and the close city. Else, if there isn't a close city that's in need, is supplying is done. We've supplied every city. There isn't a single one on the map that needs food. So is supplying is equal to false. So we need to write these three functions. So let's go through these first. We want to find city with largest surplus. So we come down here to our cities functions and we create another one called find city with largest surplus, and we take the cities into this guy. And all we're going to want to do is have a max city and a surplus value. And the max city will be equal to none to begin with, and the surplus will be 0, because you have to have a surplus greater than 0 to even be considered here. For city in cities, if city.live surplus, so that's the active surplus, is greater than the surplus value here, then we replace it. So we take the max city and the surplus values to be equal to city, so we log that city and the city.live surplus, and that just allows us to iterate through all our cities and basically bubble up the largest surplus, and then we return after this the max city. So we can actually test this. We can go up to here and we can say, now one of the things that can be super helpful to do is to highlight which is the supplier. So at the minute supplier is none, and if we're not running anything there is no supplier. But I want to actually display the supplier if we happen to have one. We'll place a yellow circle around the present supplier country. So if supplier, basically if we've assigned a supplier, then Pygame draw a circle. The screen, we're going to make it like a yellowy, not super bright. Supplier.position, we want it to be centered on the supplier position, but we want it to be a bit larger than the supplier. So we want the radius plus, let's say 4, and we also want to add a thickness value, because we don't want it to be a full circle. We just want it to be a nice sort of line going around. So I'm just going to set that to be 1 to begin with. Let's scroll that up so you can actually see it. So let's just, get rid of this exit here and the print. We shouldn't need the print anymore. And if we just run this, it should just keep iterating that this is the supplier after I press the mouse. And so we should keep seeing a circle being drawn around the supplier. So let's test this out. So here we have the map. I press the mouse and there we've got China being highlighted as the largest surplus. That's great. At least it's matching our data. Okay, so we've got that nice visualization showing us who the supplier is. Now we just need to remove this bit, or the commenting out from this bit, and we need to have a look at these two other functions. So we need to select the closest city in need. So let's begin writing a function. Select closest city in need. And I believe it will just take cities, or it will also want the supplier. Let me just scroll it up so you can see that clearly. We're going to have to iterate through each city and see that its distance from the main city, from the supplier. So we can start with a recipient min distance, and very like before, we're just going to set a default value which is much larger than the distance can be for city in cities if city.live surplus is less than 0. So if this city needs supplies and the Euclidean distance between the supplier position and the city position is less than min distance, we would set the recipient and min distance equal to the city and the Euclidean distance between those two. Then we just want to return the recipient. So we've managed to select the closest city in need. And then what we would like to do is transfer food to the recipient. So we want to define a transfer food function. Define. What we want to do is say that if the absolute value of the close city.live surplus is less than or equal to the supplier live surplus, then our stock is going to equal the close city live surplus. So effectively the absolute value. So the amount of stock changing hands is equal to that live surplus because the supplier has more than enough. If that's not the case, else, then stock will be equal to the supplier live surplus. And then we're going to use another function called move food. So it will move food between the supplier, the close city, and it will move the amount that is equal to stock. So within move food, it will take, as we've just given it, supplier, a recipient, and a stock value. And what it has to do is update the live surplus values of each. But it's not the only thing it has to do. So we're updating these live surplus values, but we also have something that we built into the class city here. We added this connections. So what we want to do is make sure we update this because we can use that then to draw lines between the cities showing where things are being moved. So if supplier.name is already in the recipient's connections, then we don't want to add it again. We just want to update the amount that supplier is sending. So we would say that supplier.connections recipient.name, because we know it's already in there, and the second value in that little list that's part of there, so it's a dictionary that has a recipient name as one part, and then it has a list which is the recipient city and the amount of stock that's being sent. We want to make sure that we add the amount of stock that's been transferred, and we can do the same with the recipient side as well. Otherwise, if the supplier name isn't in the recipient connections, we need to create it. So we'll say supplier.connections recipient.name, and that will be equal to the recipient and the stock. And we can repeat this again for the second party in this transfer. Now, you're quite right if you're looking at this going, wouldn't it be better if one of them had like a negative stock and the other had a positive stock? You're not wrong, but I'm not going to do that right now. So let's test out how this works, though you're not going to see anything because we're not drawing any connections. So let's go down here, and we want to draw the lines after we've done the background but before we draw the cities, otherwise it will just go over all the cities. Draw lines for supply connections between cities. For city in cities and for connection or con in city.connections.keys, pygame.draw a line screen. Let's just go with something bold at the minute and have just some red lines across the screen. I'm actually going to set a connection equal to city.connectionsCon. It just makes it easier for us to write things out. And we want this to be city position and connection. It's the city.position. So this should draw a line or lines between anything that's connected up. Let's see what this looks like. There we go. And it looks like China has just enough, yep, to cover the whole world, or all the deficits required across the world to get them to 0. I know this isn't the prettiest looking thing, but it just gives us an instant visual showing that this is working. And crucially, you could see the circle decreasing for China as that surplus was being consumed. Now, before we crack on with the next algorithm, I just want to tidy something up a bit, which is the color of those lines. I want to make a little function that will just allow me to get the color from the supply that's been moved between two cities. So effectively, the brighter the line, the more the supply is. So all I'm going to do is take a supply argument, put it into this little function called color from supply, and this is just within our basic Pygame display and helper functions. What we're going to do in here is just create a variable called RGB, and we're going to have our supply, and we're going to divide it by, let's say, 5 million, and we'll times that by 255. What we want to do is just make sure that we can't go above the 255 or too far below it. So if RGB is greater than 240, we'll just make it 240. And if it's less than 40, we'll make it 40. So this just gives a bit of a fade effect. And then we just want to return RGB, RGB, RGB as an RGB code. Over in the main file, so let's just save this. And we can make use of this function in this line section here. We can get the color is equal to SF color from supply, and we can take the connection, and because we just want the amount of supply, it'll be equal to 1. And then what we can do is replace this here with color. Let's see how that looks. Much nicer. Instantly you can see that there's sort of faint lines, especially over sort of here where it's not very much is being moved. Okay, small change done. Right, so as before, when we added the supplying, we're going to want to add a state that enables us to switch on the optimizing. So all we're going to do is copy the same structure. Is optimizing, and we're going to set that equal to false. And then down here we're going to want to use another button press, for example, if event.type is equal to pygame.keydown, if event.key is equal to pygame.k underscore space, then is optimizing is equal to not is optimizing. So effectively we can use the space bar to switch on the optimizing, we can use the mouse to switch on the supplying, and we can add here that we can run the supplying or optimizing algorithms. So we'll put them both in this area. If is optimizing, then we need to get a supplier again, and we'll use another function, something nice and easy like find supplier, and we'll take the cities, and we're going to have a value called city count go into there, and in fact we're going to initialize something at the top here called city count and set it equal to 0. Now remember that's there, but we'll come back to that in a moment why that's so useful. If supplier, so if we've got a supplier, then SF find and replace supplier to city, and we'll take into that the supplier and cities. So these are a couple of functions we're going to have to write. I also just want to handle city count. So if city count is equal to the length of cities minus 1, then city count is equal to 0. Else city count plus equals 1. And the thing we're going to do with this is we're going to make sure that every time we go and look for a supplier, we're actually not just stopping at the first surplus we find. We're forcing ourselves to move on each time so that we iterate through all the potential suppliers, and then we go back and iterate through again. So let's first do our find supplier. So def find supplier, we're basically going to take the cities and the city count, and for city in cities, and this is crucial where we have city count to the end of our list of cities, so we're always forcing it to move forwards a bit. We can't just take that first city. If city.surplus is greater than 0 and city.live surplus is greater than 1 million, I set this sort of limitation of you have to have at least 1 million tons of live surplus in order to move food around. Then we return the city. But now we've got our supplier, what do we want to do? We wanted to find and replace supplier to city. So let's define this. So what I want to do is initially have a checked list. Now for I in range of all of the length of the cities, so we're going to basically iterate the cities, we want to optimize the closest city in need. So we basically want to start with the one that's closest and see if it needs anything. And if it does need anything, can we replace the original supplier? Because if we're actually further away, there's no point and we might as well stop. So for city, we're going to have another function which is going to be called something like optimize closest city in need. So this helps us find the closest city. But crucially, we're going to need to have this checked list stop us from constantly always getting the city that's right next door. If city, we've now found one, actually it's in need, we need to find out if we can replace its furthest connection. So the furthest city that's connected to it equals find furthest connection. We obviously want to find the furthest connection to the city we're interested in. Now, if the Euclidean distance between the potential supplier and the city position is less than the Euclidean distance between the furthest city position and the city position, then we know that we've got a shorter connection. So if we've got a shorter distance, we can replace supplier. And we'll do that. We'll need the supplier, obviously. We'll need the city, so the two things that are now going to be talking to each other, but we also need the furthest city. We also need the stock that's between the furthest city and the one that's basically the amount of food that we've got to replace. We're looking at its connections. We've found the furthest city. So we're looking into the connection with the furthest city.name, and we're going to pull out the stock. So we're replacing that supplier. And then we'll just return because we've done it. We've switched one connection. And then we go checked list dot append city. Because if we come down here and we don't have a city at this position, we can just return to checked list and move on to the next one. So we have a little shopping list of functions we need to write. We need to have one called optimize closest city in need, find furthest connection, and we need to have one that allows us to replace supplier. So what we're going to do is we need to make sure that we take the supplier, cities, and our checked list into this function. And then we're going to do it super similar as before, recipient and min distance equal to none, and that large value just to easily replace it with something. And then for city, in cities, if city not in checked list, so super important, we're checking that it's not in checked list, and city surplus is less than 0, and the Euclidean distance to supplier.pos city.pos is less than min distance. So we can then set the recipient and the min distance equal to the city, and we can just copy that Euclidean distance function here and place it here. And then of course we just want to return the recipient, and that gives us our closest city when we're doing our optimization. If we've got a city, the next thing we need to do is find the furthest connection in that city, and you've guessed it, it's going to look quite similar. We'll have max city, max distance equals none and 0, and again it's just iterating through the connections in the city that we've selected. I need to make sure I pass that as an argument, not Siri. For con or connection in city.connections, if Euclidean distance city.position and city.connections con-0.position, so the city that's in this connection is greater than the max distance, then we're going to replace it. So max distance will become equal to this equation, and the max city will become equal to the city.connections. It's whichever city is responsible for that maximum connection. And then we return max city. So the last function that we have to write involves replacing the supplier. So what we want to do is check that if the... we need to check the arguments we've got to have come into this first. So we're going to want the supplier, the city, and the furthest city. And we're also going to want the stock. If stock is less than or equal to the supplier.live surplus, then we can completely transfer everything, because there's there's enough in the supplier that they can push all the food back from the furthest city. So we can move food from the supplier to the city, and we can make that the size of the stock, but we can also move food from the furthest city to the city, and we can make it negative. And then we can just delete the connections. So furthest city dot connections city dot name, and we can delete the furthest city connection in the city that was receiving the food. Now this is a complete transfer. So we've completely replaced the supplier in this instance from the furthest city, and we've put our new supplier in. However, if we don't have enough food, then the stock will equal the supplier dot live surplus. So we'll take everything we can from the supplier in this instance, and we can just move food. In fact, I can copy these two lines. We'll save this, and well, we need to see whether it works. So we can start by observing the selection where we're pushing food from the largest surplus to all of those that have a deficit, and then pressing spacebar, we can see the optimization occurring across the map, slowly pushing from different surpluses to places and pushing the food all the way back to the larger surplus that was originally used. So there we go, that's how easy it is to set this up. And in fact, if we wanted to do something like check what 0.6 of a ton a year would give, we could easily change these numbers up here and run the simulation. And here we go. You can see that actually just that small change makes things spread a little bit more and increases complexity when we're looking at the redistribution. Well, that's the end of this tutorial. There's a lot of things you could do with this and a lot of ways it could be improved, but I hope you've enjoyed it. It's a lot of fun to code up. It was a fun project. And if you did enjoy it, give it a thumbs up. Why not leave a comment and maybe subscribe? Thanks so much for watching, and I look forward to seeing you in the next one. Bye!